Hello viewers, welcome to this session. Here in this video, we are finding the conditions of both common roots of pair of quadratic equations. Let we are taking two quadratic equations. One is a1x square plus b1x plus c1 equals to 0 and a2x square plus b2x plus c2 equals to 0, provided a1 and a2 not equal to 0. We want to find the condition for both the roots common. Before we start this one, we first recall that sum of the roots of a quadratic equation ax square plus bx plus c is equals to 0. If alpha and beta are the roots, then alpha plus beta is equals to minus of coefficient of x by coefficient of x square. So, when the equation is ax square plus bx plus c is equal to 0, then sum of the zeros alpha plus beta is equals to minus b by a. Minus b is a coefficient of x is b, so minus b by coefficient of x square, that is a. And product of the roots is equals to constant term, that is c, by coefficient of x square, that is a. So now in this, let alpha and beta are the roots of both the equation. And our equations are a1x square plus b1x plus c1 is equal to 0. So for a1x, b1x square, b1x plus c1 is equals to 0. Alpha plus beta is equals to minus of b1 by a1. And alpha beta, that product of the roots, is equals to c1 by a1. Now our second equation is a2x square plus b2x plus c1 is equals to 0. So since alpha and beta are the roots of this equation also, so we are getting alpha plus beta is equals to sum of the zeros, that is b2 by a2, and alpha beta is equals to c2 by a2. So clearly these two values are equal. So we can write that alpha plus beta equals to minus b1 by a1 is equals to minus b2 by a2. This implies b1 by a1 is equals to b2 by a2. You can write a1 by a2 is equals to b1 by b2. Numbering this one as equation or relation 1. And then now from these two, alpha beta c1 by a1 is equals to c2 by a2. So from this, also by arranging, you can write a1 by a2 is equals to c1 by c2. So this is if we marked 2. So from 1 and 2, we get the condition for both common as A1 by A2 equals to B1 by B2 is equals to C1 by C2. Now tricks. If two quadratic equations with real coefficients have one imaginary root, say alpha plus I beta, is common, then the other common root is must be its conjugate, that is alpha minus I beta. So if in a quadratic equation, say for example, if 2 minus 3i is a root of a quadratic of both the roots of a root of both the equation, then other root must be other common root must be 2 plus 3i. If two quadratic equations with real coefficients have one irrational root, and that is common, say alpha minus beta, then here also other common root would be alpha plus root beta. Third one, if alpha is a repeated root of a quadratic equation, if x is equals to ax square plus bx plus c equal to 0, then alpha is a root of f dash x, that is its derivative, 0. So here the derivative of ax square plus bx plus c is 2ax plus b is equals to 0. So this gives that x is equals to minus b by 2a. Say for example, 4x square plus 4x plus 1 equals to 0. We can find the roots of the equation as by differentiating this, we get 8x plus 4 is equal to 0, and this gives x is equals to 4 by minus 4 by 8, that is minus half. So one root of the quadratic equation is minus half, and the other root, as it is repeated, also minus half. If alpha is a repeated common roots of two equations, fx is equal to 0 and gx is equal to 0, then alpha is a common root of f dash is equal to 0 and g dash x is equal to 0, that is f dash alpha would be 0 and V dash alpha is equals to 0. Thank you for testing your understanding of this lesson, and more videos log on to www.tubelessons.net.